Okay, this is the final exam review for Math 110, starting with number 25. Solve using the square root property. The quantity 2x minus 3 squared equals negative 16. All right, so the deal here is we have something squared equal to a number. And when that's the case, you can use the square root property. Square root property basically says that if x squared is equal to some number, then x is plus or minus the square root of that number. It's just definition of squaring. And definition of square root could be positive or negative, kind of like if x squared is 4, then x could be positive or negative 2, because either one of those squared gives you 4. So here we have this quantity squared equals negative 16. So that means you can take the square root of both sides. The square root of something squared is just that something. In this case, 2x minus 3. Basically, the square root undoes the squaring. And then you have to realize it could be positive, could be negative. And then the square root of negative 16 is imaginary, right? The square root of the negative is I, the imaginary unit. And the square root of 16 is 4. So this is plus or minus 4i. So then you solve for x. You get 2x equals 3 plus or minus 4i, adding 3 to both sides. And then you divide both sides by 2 to get x equals 3 over 2 is the real part, plus or minus 4i over 2 reduces to 2i. So you have the complex conjugates, 3 halves, plus or minus 2i. All right, number 26. Solve using the square root property. Oops, there we go. 3x squared minus 7 equals 8. All right, so 3x squared minus 7 equals 8. Here we have to first solve for x squared. So add 7 to both sides. X squared equals 15. Divide both sides by 3. X squared, x squared, I don't know where that came from. X squared is 5. And then square root of both sides plus or minus the square root of 5. And those are your answers because they don't simplify. Number 27. Solve using the quadratic formula. 2x squared minus 5x plus 1 equals 0. So here's where you have to have memorized the quadratic formula that says if ax squared plus bx plus c equals 0, then x is going to be equal to negative b plus or minus the big square root of b squared minus 4ac all over 2a. All right, so that you have to memorize. And I like to do it in 2 steps. This number under the radical is called the discriminant. If you calculate that first and then plug it in, it makes it a little bit easier. So that's what I'll show you here. So we've got a equals 2, b equals negative 1, and c is positive 1. So b squared minus 4ac, b squared minus 4ac is negative 5 squared minus 4 times 2 times 1. So that's 25 minus 8, which is 17. All right, so then the rest of the quadratic formula says take the opposite of b, so that'll be a positive 5, plus or minus the square root of the discriminant, 17 in this case, all over 2a. A is 2, so 2a would be 4. And then you simplify it if you can, but this one doesn't simplify, so those are the answers. Number 28. Solve using the quadratic formula. X squared plus 7x minus 2 equals 0. And you might notice that that doesn't factor because it'd have to be x plus 1, x minus 2, or x minus 1, x plus 2, and neither one of those gives you 7x in the middle. So the quadratic formula is the way to go. B squared minus 4ac, again, first of all, is 7 squared, 49, minus 4 times 1 times negative 2. Right, because b is 7, a is 1, there's a 1 there, and c is negative 2. All right, so that's 49 plus 8, which is 57. And so x is negative b, negative 7, plus or minus the square root of 57, all over 2a, which is just 2 in this case. And 57, I don't think there's any perfect square factors in there. 57 is divisible by 3. Yeah, 3 times 19. No perfect squares. So that is your answer. All right, number 29. Determine the equation of the axis of symmetry, the coordinate of the vertex, coordinates of the vertex, and write the following parabola in the form y equals ax minus h quantity squared plus k. All right. So we've got this quadratic function now, y equals 2x squared minus 8x plus 1. All right, so first of all, you can do this on your calculator. You can graph it. I'll show you that as well. But by hand, you can find the vertex using the formula that h, the x-coordinate of the vertex, is always negative b over 2a. Okay, so that's just something to remember, memorize, kind of like the quadratic formula you need to have memorized, and the equation of the circle, the square root property, stuff like that. You just have to know, so you have to study those things. All right, so here, h, the x-coordinate of the vertex, is the opposite of negative 8, so positive 8. That's negative b, over 2a is 4. So h is 2. All right, and then k, the y-coordinate of the vertex, you get by just plugging h into the function for x, just like you would for any point. Basically what you're doing is you're looking at, if you have a table, if x is 2, what do you get for y, right? You just plug it in for x. You're going to get 2 times 4, which is 8, minus 16 plus 1, which is negative 8 plus 1, or negative 7. So the y-coordinate of the vertex is negative 7. All right, so then you can plug it into this vertex form of the equation of a quadratic function. The coefficient a here is the same as the a here. So that's 2. H is 2. And k was negative 7. So minus 7. So there's your vertex form. The equation of the axis of symmetry is always x equals the x-coordinate of the vertex. So x equals 2 is the axis of symmetry. Because what's going on here, if you look at a graph, you've got a vertex at 2, negative 7. So over 2, down 7. 1, 2, 3, 4, 5, 6, 7. So that's the vertex of your parabola, and this one's opening upward because that coefficient is positive. So it's going to, be this kind of U-shaped thing with the vertex right there. The axis of symmetry is the line that cuts it in half, and so it always goes through the vertex. So that means whatever the x-coordinate of the vertex is, 2 in this case, is where it hits the x-axis. And any vertical line that hits at the x-axis at 2 has equation x equal 2, because every point on that line is 2. Has x-coordinate 2, I should say. All right, what else did they want? They want, that's all. We could do a couple extra things in case they ask. For the intercepts, if you plug in 0 for x, you'll get the y-intercept. That's an easy point to find. That's plugging in 0 here and here, so those terms go away, and you just end up with a plus 1. So the y-intercept, where it hits the y-axis, is at 0, 1, right there. And then the x-intercepts are an application of solving the quadratic equation. When you set that function equal to 0, plugging in 0 for y is how you get your x-intercepts. So let's see what happens when we set 2x squared minus 8x plus 1 equals 0. Don't think that factors. So let me use the quadratic formula, starting with b squared minus 4ac is 8 squared, or negative 8 squared, either way, is 64, minus 4 times 2 times 1, which is 64 minus 8, which is 56. So x is negative b plus or minus the square root of 56 all over 2a, 4 in this case. And then 56 does have a perfect square in it. If you break that down, well, it's 7 times 8, and 8 is 4 times 2, so it's got that perfect square of 4 in there. So you can take the square root of 4 out of the radical, and there's 7 times 2, or 14, left inside the radical. And then you can divide each of those by 4 and get 2 plus or minus root 14 over 2 when you reduce that. So those are the x coordinates of the x-intercepts. So to graph those on the graph, of course, you would want to approximate them with a calculator. Square root of 14 is going to be a little bit less than 4, just because 14 is a little bit less than 16. Divided by 2 is going to be a little less than 2, so you're going to be adding and subtracting a little less than 2 from 2. That means, yeah, so that means you're going to be pretty close to 0, subtracting a little less than 2 from 2, and pretty close to 4, adding a little less than 2 to 2. You can see they're symmetric around the axis, as they should be. In fact, there's another point you could plot that's the mirror image of the y-intercept around the axis of symmetry. And then you can draw in the parabola going through those points as best you can, kind of a U-shaped graph like so.